Well, howdy. We're now finished with the theory, and we're going to show you how the instrumentation works today. We're going to start off with gas-filled detectors, just like we started off in our lectures. And the first thing we're going to play with is the Geiger counter here. You can have them all hooked up with NIM bins like you see here, but this one is your basic handheld Geiger counter, and it seems that there's radiation in the room. Well, gosh, since we're here to study uranium, I have brought a source for us. This is Fiestaware, and the nice orange color that you see there actually comes from uranium. And to give you an idea of how radioactive it is, on a ×1 scale, I can make this go off scale. Okay. Well, that sounds pretty scary, and actually I must be a brave man to sit here next to this radioactive plate. But just between you and me, your grandmother probably ate breakfast off plates like this, and they managed to live a long and useful life, most of them. So here's our second gas-filled instrument, and this is an ion chamber. Inside here is a cylindrical chamber. He measures alpha, beta, gamma, and has readings in micro-R. Right now, the radiation field is about 1 micro-R, 1 to 5 micro-R per hour. And if I set it on the plate, oh my gosh, we're up to 13, 14, 15 micro-R per hour. So this gives you an idea of how sensitive the Geiger counter is. That what is a small fraction of your annual dose that you get from background radiation drives Geiger counters completely off scale. The next gas-filled detector we're going to talk about are BF3 tubes. And this unassuming tube right here is a boron trifluoride neutron detector, as we talked about in class. This one is older than dirt. It was actually calibrated in 1978, which I'm sure is older than most of you here. And using this, we get a look at the other parts of a NIM bin. The important parts are we will hook this to the preamplifier, which feeds the high voltage through it to the detector, and then does shaping and inductance. Okay, and so this detector is hooked to the preamp, and the preamp does a couple of things. You feed the high voltage through it to the detector, and it provides shaping of the signal that comes back out and impedance matching, so you get maximum signal returned along the cable. It's fed into the amplifier, which is like the volume control on your stereo. I can make the pulses larger or smaller, and then from there we will feed it to the computer that acts as our MCA. Along the way we have our friend the oscilloscope, so that we can look at the pulses and debug what's going wrong, because something will always go wrong. So let me go hook up the source. Let me go hook up the detector, bring in the source, and we'll go from there.